All right, so in this problem, we have double radicals, and these double radicals cannot be combined. You can't go in and combine their insides or their radicands. This is a technical term for that. Um, so what we're going to do, the technique we used was to send this radical over to the other side. And then we'll square both sides. You could square both sides at the very beginning, but it ends up with some pretty complicated foiling there. So we're going to split them up and keep root x plus 7 on the left. When we add the root 8x over to the other side, it's positive, so I'm going to list it first, and then the minus 1 after it. So now we can go ahead and square both sides. Squaring this will be a little bit cleaner than if we would have squared this. Okay? Left side works out very nicely. The radical gets canceled by the square, so we just have x plus 7. On the right side, you have to keep in mind that this is not true. And I'm still seeing this in some of your work. I saw this on the one worksheet that I was checking. People did that x plus 6, and when you squared it, you got x squared plus 36. That's not true. You have to remember that when you're squaring a quantity like this, there's a minus 2ab in the middle, and then b squared is positive, because you end up negative b times negative b is positive b squared. All right, so we're going to use this rule. Whoa, I don't know where that red line came from. We're going to use this rule right here to square this. So we take the first term squared. So it's going to be root 8x squared, which is just 8x. In the middle, it's going to be negative because of the minus here. Double a times b. Root 8x times 1 is just root 8x plus b squared. So plus 1 squared is 1. So now, when you have another radical involved, so it didn't completely get rid of the radicals from the problem, we still have one left over. So at this point, we want to get this term by itself and get everybody else over to the other side. Kind of the opposite of how we solve quadratics. We're going to take away 8x. We're going to take away 1. Keep it balanced, do it to both sides. Take away 8x, take away 1. So on the left, you're going to get negative 7x plus 6. Cancel, cancel. We successfully got this term alone. Now we just have to square both sides again. So sometimes you have to do the same technique over again in order to get the radical to completely go away. So we have two different rules at play here. On the left, you have an a plus b. You have a sum being squared. On the right, you have a product being squared. Two different rules. On the right is the old a squared plus 2ab plus b squared. Very similar to what we just did. On the right, however, this is a product, not a sum. When it's a product, you're allowed to just square a and square b. Let's do the right side first because it's easier. So all we do is negative 2 squared, which is 4, times root 8x squared, which just cancels the radical. You still have an 8x there. Not 64x. You don't, not 64x squared, just 8x. It cancels the radical, 8x. On the left, we have to do our foiling rule. So negative 7x squared is positive 49x squared. In the middle, you have double the product. So double negative 7x times 6. That's negative 42x. Double it for negative 84x. Then last, you have b squared. So 6 squared is 36. Suddenly we have an x squared equation. We have a quadratic now. So it went from being a radical, squared both sides. It was still a radical. We isolated the radical and squared both sides. But now that it's an x squared, everybody comes over to 49x squared side of the equation. This is a 32x, and we're going to subtract it from both sides. Some pretty heavy-duty factoring coming up. 49x squared minus 116x plus 36 equals 0. Surprisingly, it is factorable. This does factor. It doesn't really reduce at all. Kind of wished it did. Like if we could divide every term by the same thing, maybe we could cut it down a little bit. If you're intimidated by factoring this, and some people are, you could use the quadratic formula. Anytime I draw a circle with the disappearing pen, it takes 10 seconds to turn into that little spotlight, so that's my bad. You could use the quadratic formula if you'd like. You could graph, right? You could make a parabola and find out what its x-intercepts are. That's how you could solve this. But I'm going to go ahead and factor it because it does work out. It's factorable. There's a lot of trial and error involved in factoring sometimes, especially with something as crazy as 49x squared. So I tried lots of combinations with 7x and 7x, right? And then a 36. I tried a 6 and 6 here, and then both minus. I tried a 2 and a 18. I tried 4 and 9. Nothing worked. So then it became obvious that maybe it's not 7x and 7x. What other way can we make 49x squared? 49x and 1x. Actually worked out fine. And turns out to be 49x minus 18, 1x minus 2. Let's just check that. Out here, you would have negative 98x. In here, you'd have negative 18x. And they indeed add up to negative 116x in the middle. So that is the factored form. Meaning that your potential solutions are x equals 18/49 or x equals 2. This is the good solution. This turns out to be extraneous. So all that to get x equals 2 as your solution. I am going to want to see this work on your test, so be familiar with these problems. Checking 2 to make sure it works. Is the square root of 2 plus 7 minus the square root of 8 times 2, negative 1. That looks like 9. Its square root is 3. This looks like 16. The square root is 4. And works out. Not sure that 18/49 does. Let me stop the video there and see if you have any other questions.